Hello everybody and welcome to the APAC BRICS Summit Southeast Asia edition. My name is Rashmi Anand and I head marketing for BRICS in this region. If you have missed our global summit in October, don't worry. We would be covering all the key topics in this session. There are external speakers who will give you a better perspective on how BRICSCAT is ready to shape a digital tomorrow. V21 is one of our key launches this year. We have enhanced our 2D automation and 3D modeling capabilities with AI-based parameterization features, applications like Twinmotion and civil design. There are many more exciting features that we can't wait to show you. So hold your breath. We have a jam-packed agenda for this afternoon. Let's kick off. I would like to invite our Vice President APAC, Chris Lee, to share BRICS' vision for next year.
Thank you, Rashmi. Good day, everyone, and a warm welcome to BRICS' APAC headquarters in Singapore. I'm Chris, VP for APAC at BRICS. It is a great pleasure to welcome everyone to BRICS' Digital Summit Extension for Asia. At BRICS, we deliver on the promise of DWG. It is our customers and the technology that we build to serve our customers that matter at BRICS. We are a global provider of an affordable computer-aided design application for building information modeling, mechanical design, as well as a SaaS-based common data environment platform. Over hundreds of thousands of customers in both manufacturing and AEC industry have trusted BRICS. We are now part of Hexagon AB, a global organization with more than 20,000 employees. BRICSCAT technology is always ready for production. The launch of V21, a proven track record technology and innovation in a complete end-to-end 2D, 3D, BIM, mechanical design, and collaboration platform. BRICS aim to help our customers to be ready for the future. At BRICS, we recognize there is no time for status quo in this highly competitive world. And that's why we emphasize on continuous product development and improvement. BRICSCAT is always ready for open collaboration. We don't limit our customers to proprietary format. And that's why we will support native Revit RVT, MicroStation DGN, and additional to the DWG, we will support customized mechanical and civil 3D in our latest V21 release. To improve collaboration in product data management, the integrating of the industry-leading immersive visualization and engineering application, we have developed a comprehensive partnership through our highly compatible API and SDK to support an extensive network of third-party application and user base. And in enhancing our digital construction solution, you will hear more about BRICSCAT integration with Leica Geosystem, world-leading high-definition surveying technology, allowing our customers to deliver an end-to-end experience for BIM to field as well as field to BIM. BRICSCAT is now available globally, and we don't limit our customers to just one subscription model. We offer our customer both perpetual as well as the licensing in the subscription option. Customer can continue to enjoy the benefit of both worlds. On top of that, customer can also use the network deployment and scale with non-NIM user. We support the network of global partners and third-party application. Our global reach has now extended beyond APAC to North America. We are pleased to support customers through this network of comprehensive commercial centers that bring us closer to the customer. Through today's journey, you will join our list of distinguished customers to witness Brix's offering and how we bring more values to you and experience the benefit of DWG. We believe in the future of DWG. Let me now introduce you to Maurice, our Head of Business Development for ASEAN region, who will take you through this journey and begin your experience at Brix's Digital Summit. Thank you.
If you did not hear about BricsCAD Mechanical before, then you probably consider it as just another toolset to create 2D mechanical drawings. While 2D drafting is perfectly possible with BricsCAD, we at Brixis strongly believe in 3D. Three-dimensional modeling allows designers to fix errors at early design stages, analyze different aspects of design products, generate NC code and technical documentation. While BricsCAD Mechanical is not a toolset for 2D drafting, it is also not just another mainstream 3D mechanical CAD. There are serious differences of BricsCAD from other MCAD softwares. First of all, with BricsCAD, you don't need to spend your time and money to study a completely new software with its own GUI and design principles. With BricsCAD, you always remain in the same familiar environment, which was extended with few intuitive tools. Secondly, with BricsCAD Mechanical, you will be more productive in design thanks to our unique technology of 3D parametric components and hundreds of vertical applications from our partners. You can easily implement your own tool or application using our Lisp or VRX API. Third, BricsCAD does not pretend to replace your current CAD system. It is ready to collaborate in multi-CAD environment. You can continue to use your different CAD tools, but with BricsCAD, you will never have headache with file formats, which lose design intent in translation. I believe no other CAD system in the world has so powerful tool set to rework imported geometry using a combination of direct editing operations with automatic history-free parameterization. Each year, our quality assurance engineers test new functions of BricsCAD Mechanical on a completely new model. This year, we were inspired by the idea of Maltese cross mechanism. This is a gear mechanism that translates a continuous rotation of the driving wheel to an intermittent rotation of the driven wheel. It was modeled in BricsCAD using 3D constraints and expressions. And this movie was recorded in BricsCAD using Animation Editor, which allows you to create complex scenarios of 3D parametric animations with different effects, including appearance or disappearance of particular parts, kinematic simulation, and camera movement. As you can see, this Maltese cross mechanism is a sub-assembly of the filling and capping machine. Through a conveyor, the bottles are moved under some filling valves that inject the liquid into them. After the filling, the bottles move up to the other side of the machine where a cap is provided for each of them. This model also has parameters, which allows to adapt it to bottles of different size. It is a large assembly which consists of more than 3,000 parts, of which 500 parts are unique. And this machine is part of a brewery which also has a lot of vessels connected with pipes to a water supply and the machine. A number of standard parts are used here, which is also typical for many other industrial assemblies. This complex model was designed in BricsCAD Mechanical from scratch using new and improved tools available in version 21. This year, we implemented the most popular suggestions of our customers and partners and extended the main tool sets, which are sheet metal design, assembly design, and technical documentation with the most requested tools. Let's take a look at these new features with the help of this brewery model. There are a significant number of very useful new features in sheet metal this year. Let us take a look at the most powerful of them using two sub-assemblies of the capping machine. In order to demonstrate the new intelligent way to create sheet metal parts from simple solids, we will be using this control box. Let's convert them to sheet metal, and now for the bottom part, you can see that on clicking on the top face, bends, junctions and reliefs are created automatically at the same time. That's really wonderful. For the middle part, we just click on two faces, the back and the front, and everything is being automatically created. We just have to choose the kind of miter which is very fast using the amazing propagate capability that looks for similar geometries and automatically applies the miter. In matter of seconds it is done and we can unfold the model. That is really amazing. Let's go now to the top part. First we create the bends on the top face. You can see that the related junctions are automatically being created here. Then we repeat this on the two back faces. Everything is created automatically except for the miters, which again can be placed using the propagate capability, and it's just a matter of a single click. Now let's try creating the curved junctions on the bottom and on the top curved edges. We will be creating the junctions here. This looks really easy. We still need to make some minor changes to unfold this part. Thanks to the possibility to switch bends and junctions, we will be swapping the bends with the junctions on the two sides. Now we will be able to unfold the part. Another important new capability is the possibility to assign one body with its specific properties, despite the fact that we had converted all the parts together. Here we are going to change the thickness of the bottom part. And you can see here the thickness is updated for the bottom part alone, and the rest of the components retain the original thickness. And now we will go ahead and unfold all the parts. You can realize that in less than 4 minutes we have converted the three solids into sheet metal, and we have also unfolded them. That is really amazing here. Next we will be using this drum feature that distributes the caps that will be crimped on bottles to showcase some advanced features in sheet metal. We start from the shell state, what we call as poor sheet metal in BricsCAD language. First we convert them to sheet metal. Now we are going to add the bend to this small part that you see here. But you see there is a gap at the flange end. Now we will be filling this gap using the sheet metal junction. Then with our new T-tabs function, we can switch this junction to a tabs and slot inside the flange, and not only at the corner. Look at this result here, that's really amazing. But this is editable. We can change any parameter. For example, we can change the number of tabs to 2, and it is going to still retain the symmetrical feature. Now we will add two small flanges to guarantee the perpendicularity, and let's try to fix the width to maintain the design intent. Let us see how the tabs are going to behave when we try to move them by moving the flange using the push-pull command. The tabs and slots are going to move accordingly, and the design intent is being maintained. Even when we try to rotate the flange, the tabs and slots are going to move correctly. Then thanks to the new capability of BricsCAD 21, we can change the thickness of this part, and you can see that the tabs and slots are actually changed, and the design intent are also respected. And you can see there is no collision here. And of course, we can unfold this as well. Things get even better with this next capability. What about tabs on curves? First, let's set up a number of tabs to 0. It means that the number will be chosen automatically according to the distance that is being selected. Now just click on the round edge and let's see the miracle. We are going to get the tabs with the perfect distribution. Of course, we must create a junction to separate the parts, and let's do that here. And now to finish, just select the remaining parts in the rectangle and click on the create bend. These solids are now fully converted to components which can be successfully unfolded. Finally, we can go ahead and unfold all the parts. If needed, these drawings can be exported to DXF file format as well. All these features will help us to save a ton of time during the design process. But there is one more kind of part which is also very typical in the mechanical engineering. These are seamless and welded pipes, elbows, T's, crosses, reducers and flanges, also called as pipe fittings. They are widely used in machinery, automotive, aviation industries and also in oil and gas. In BricsCAD B21, we added a rich set of such parts of the most popular standards. We also streamlined the way to insert and connect them. The bottom-up design was never so easy, and we keep the freedom of direct editing in combination with full parametric control. Let's see this in action. I want to show you some cool new features and tools which we have prepared for piping design. Let's go ahead and showcase this with the brewery model, which was created from scratch in BricsCAD. As you can see, this model contains around 800 parts and more than 1000 constraints between them. All these constraints were added automatically and during the new mode of BM insert command, which is called the smart insert. Let's check that even with such a big number of constraints, this model is workable. For example, to have access to the vessels, we need to add a platform between them. The original platform looks very big, but fortunately it is parametric, so you can easily change its dimension to adapt to the actual situation. Here we need to change the height and the length. As you can see now, we have a problem. There are few intersections between the inserted platform and the existing pipe layout. We cannot change the platform since we want it to be as small as possible to save useful area. So we go ahead and change the pipe's layout. But actually, it's not a big problem. Since pipe layout is properly parameterized and we can just move it by manipulator or the move or the DM commands, and everything is going to move. For example, the placement or the pipe lengths will adapt automatically. So we need to move just one pipe and the whole line will move properly. There is still intersection with the valve, so let's move it also. Since our brewery has become bigger and bigger, workers will not have time to do everything manually. So we want to upgrade it by adding some automation. For example, by adding the filling line here. I think you remember this filling line. By sheet metal demo, we had used this filling line here. Here is our filling line and now it looks like everything is ready for connection. But we cannot directly connect the filling line with the layout. We need to add a pump. This pump will transfer the beer between the filling line and the vessels. We do not want to place the pump in front of the required flange because it will block the passage. So what we actually need is to place the pump behind the flange, but it again will cause of some modification of the existing layout for proper connection. So first what we do is we rotate the elbow with the flange. It can be done by any rotation command or just by manipulator. Such operations will preserve all required constraints, so layout still can be modified properly. Then we need to connect flange to the pump. We can just directly move it there or use the BM connect command, which was implemented to connect two components which have information about how they should be connected. As you can see, the outer diameter of the existing layout does not correspond to the pump diameter. But again, we have properly parameterized the layout, so we can adapt diameter by just changing one parameter. So flange, the adjacent pipe and all the other connected pipes and T's will change their diameter properly. Let's continue. Now we want to connect the pump to the filling line. We can do it easily with the help of a new standard parts library and a new option of BM insert command called smart insert. Standard parts library I have reconfigured to improve the usability. All existing parts are separated in three categories: fasteners, machine parts, and structural shapes. The category of piping with the 182 new parts are also added. Mostly it contains parts from the American standard, the German standard, and also the international standard, which is the ISO. Currently, piping categories include following parts like pipes, fittings, like elbows, returns, reducers and eccentric reducers, T's and crosses. A lot of different flanges as well. And finally, there are also the gaskets. So if we will drag a piping part from the library, by default, the Smart Insert mode of the BM Insert command will be used. This mode can be used on components which store inside information about how these components should be connected to each other. This information is stored as point and line on special layers with the postfix connection. These entities represent connection point and the connection direction. Also, this mode recognizes which parameters of the base component can be used in inserted component and try to copy values or expressions of such parameters. This allows inserted part to adapt to base 1 and also will allow to create parameterized layout. One more thing which allows to create parameterized layout is proper constraining. So Smart Insert analysis inserted and base parts and decides which constraints should be added to them to allow correct further working. We continue with the creation. As you can see, when you hover inserted parts to base 1, its size is being changed. It will properly connect to base 1. Moving and rotating of such parts is still available and does not spoil the parameterization. Moreover, because of constraints, adjacent elements are adapting to the move. Smart Insert can be used not only from library but also on already inserted components. As a final step, we need to actually connect the created pipes to the filling line. Here, for that, we are going to again use the move command, but in that case, we need to position everything correctly. But we can also do so using the specialized BM connect command, which will do it automatically. You only need to point out which two components should be connected to each other, and you can see here using BricsCAD 21 it is possible to create the parameterized pipe layouts which can be easily changed if needed. We just saw that assembling large parametric pipe systems in BricsCAD Mechanical is as simple as connecting Lego parts together. But to manufacture these assemblies, one has to properly generate the corresponding technical documentations as well. Let's see how to solve this task with BricsCAD Mechanical. In V21, we implemented new powerful tools to create associative two-dimensional drawing views from 3D models of mechanical parts and assemblies. Let me demonstrate these tools to you on the example of the beer vessel. According to the standard, the main view for the vessel is the section view. To achieve this, first we should create the base views beyond the layout and then create the section of the side view. Also, we can create the top and the bottom view. They can be later on annotated. The next part of the vessel are the most important. They are responsible for preserving the contents of the vessel. The middle manhole sub-assembly does not completely fit into our drawing, but we can easily change their scales using the command option. The command option allows us easy customization during the view creation. The next step is not so obvious and could take some time because the sub-assembly orientation is not known. It is not aligned with the coordinated axis. That's why to create the correct view for the top manhole, we use the view base command with the current orientation option. This option inherits the camera position from the model space and uses it in the drawing view. It allows to create the custom view quickly and easily. The space on a layout is limited. We also plan to add annotation tables and technical notes in the future. In V21, we introduced the new break view command that can reduce the drawing view area by hiding the fragments. Let's create a vertical dimension and check how it behaves with the break view. Now you see the vertical dimension keeps the correct value after the brake operation. The brake symbol has several properties. You can change the type of the symbol. For example, you can change it from spline to zigzag. And other parameters such as distance between the curves can also be changed. We support vertical and horizontal cuts and can combine both on one view. Fixation of the manhole door is achieved by using a threaded pin and knob. We've implemented the new DM thread command, which allows to create a decorative thread to display on the drawing view. Let's open the pin component and add the thread. Using the new tool, we can easily create the thread on any cylindrical face. You can configure the pitch, the length and the diameter of the thread. Let's switch to the main assembly and create a drawing view of the pin. You can see that the threaded model displays correctly in the drawing views. We've put all the necessary views on the drawing. It will be finished later. Now I propose to switch to another drawing, a very special one. Our project partners helped us with a couple of drawings, but they have preferred to work on an old style manner using AutoCAD Mechanical. Unfortunately, after receiving the drawings, we've noticed several mistakes that must be corrected. By default, when you open an AutoCAD Mechanical drawing, some specific symbols represented as proxy objects. To be able to apply changes to these objects, you need to activate the Mechanical 2D enabler like what we have done just now and reopen the file. After that, you can modify the 2D elements. We are supporting copy, move, erase and other basic operations, but our capabilities are even wider. For example, you can see here the datum ID is being copied using the manipulator. In V21, we added the ability to change the properties for 2D elements from the property panel. We've corrected the feature control frame properties and now replacing the surface finish symbol. Another example illustrates the assembly drawing. It allows us to demonstrate the ability to change the balloon properties such as the balloon type. You can change it from circular to polygonal and arrowhead style. In our case, we use a standard arrow. We see that the part list overlaps by other balloons. So we have to correct this mistake and at the same time edit the support bracket material. All these manipulations will take us just a few seconds and we did not ask the author for this document for any help. The next step in documentation in most mechanical drawings are tables. It can be a trivial part list or something more sophisticated. Bill of Material Manager of BricsCAD Mechanical allows you to create many kinds of such tables, and since V21, its capabilities became absolutely fantastic. I'm going to show you the most interesting features of Bill of Materials in BricsCAD V21. Let's start with this brewery model. With more than 3000 parts here, you will need a fast, flexible and powerful tool to document and analyze. Good news is that the Bill of Material in BricsCAD does exactly that. For example, what if you want to see only the parts related to pipes, which this model has a lot? To list only the parts related to the pipes, we will add the part category column and use a new feature of BricsCAD V21 called column filters. Column filters allow you to quickly set criteria to show the rows which we need, similarly to the spreadsheet processors. Here, we use the filter to select only the part categories related to pipes such as the elbows, flanges, pipes, reducers and tees. This table now shows all the parts related to the pipes. But what if you want to know the total length of the pipe by the size? To find out, we copy this table and adjust the filter to show only the pipes. Next, we remove the component column and add the size and length properties. Normally, BricsCAD groups parts with respect to their components. In order to group pipes by their size only, we need to change the grouping mode to by columns only. In this mode, parts will be grouped only by the added columns, which is exactly what we need. To get the total length for each pipe size, we use another new feature called the aggregated function. Similar to the footers, they can also compute the sum, average, minimal or maximum value in the group. And you can still add them to the footer. Additionally, you can also set a column filter to find a specific range. let's say in this particular project, I want to see only pipes between 50 and 100 meters long. This can be easily done using the aggregate function. Aggregate function and the column filters form quite a powerful tool, and we hope you liked it. Now, let me switch to a familiar drawing of the maturating vessel. It's almost ready now, and all we need to do is to add some specifications and annotations. Let's start with the material list. First, we create a bottom level bill of material and rename all columns to meet the company's standard. For pressure vessels, materials and dimensions for each part are also required. So we add the necessary columns such as the physical material, the part category, the part number, and the length. However, we want dimensions to be in one single column. So we create a template column from the selected ones. It's a new feature to combine several properties in one cell. It's based on the so-called diesel expressions. So even quite complex templates with conditions are possible. BricsCAD automatically adds delimiters between values, which you can adjust with your own text. Of course, you can configure template columns as you want using this template configurator dialog. Now all we need to do is to remove no longer necessary columns and add the table to the drawing. And now it's done. Isn't it impressive? Of course, we've highlighted only the most spectacular new features of the bill of material, but there are more. Please try them using the BricsCAD 21.